Hi, guys. Okay, so in this video, we are going to look at the pre-algebra concepts that are applied in an introductory chemistry course. So we are going to cover, so first of all, a very basic number sense, the integers. Then we're going to look at the rounding up numbers and, the concept of addition and subtraction and the using of calculators and solving equations, then solving problems using the order of operations, then fractions, how the additions and subtractions and the multiplication is used, and then solving equations with fractions, radical expressions, simplifying, graphing, conversions, percentage, and statistics. So I'm hoping I'm able to cover everything. And so that's why this is going to be a little bit fast-paced. So first of all, reading numbers. Okay. So can you understand, the place values of the number? Do you understand where 1,000 is, where ones is, where tens is? The place values. Okay. So reading numbers. So thousands, hundreds, tens place. And then the units place or the ones place. Where is it? Okay, commonly sometimes it's called ones also. Okay, so for example, if I give you a number like 2, 6, 3, 7. So can you read it? What does it mean? It means that the 2 is in the thousands place, 6 is at the hundreds place, 3 is at the tens place, and the 7 is in the ones place. Okay, so then this number becomes 2,637. Okay, but if a number is given to you in this way, 2.637, what does that mean? That means that 2 is in the ones place. In this case, 2 is in the units or in the ones place, but 6 is in the tenths. 3 is in the hundredths, th, and 7 is in the thousandth. Th. So you see, with the decimal, the placement has changed. So these numbers now are this sound, the sound. Okay, which means fractions. Okay, so now let's look at some of the way we express them in fractions. So now I have written the number 2,637, and the other one is 2.637. So that's how you would say it. Okay, now let's understand this placement a little bit more in the terms of power and placement. So for example, if you have something like 10,000, this means 10 times 10 times 10 times 10. And the way we can write it is also, so this is equal to 10 raised to the power 4. Okay. Similarly, if you have something as 1,000, so there are 3 zeros, and here you have, this means 10 times 10 times 10 times, just this much, and then that is equal to 10 to the power 3. Okay. Similarly, if you have 100, then this is 10 times 10, and this is equal to 10 to the power 2. Okay. On the other hand, if you have something in the terms of decimals, so in the terms of decimals, like 0.1. So what does that mean? 0.1, it means 1 over 10. 1 divided by 10, or 1 over 10. And that means 10 to the power minus 1. Okay. Similarly, if you have 0.01, 0.01 becomes 1 over 100, and that is equal to 10 to the power minus 2. If you have 0.001, this means 1 over 1,000, and that becomes 10 to the power minus 3. And if you have 0.0001, then that is equal to 1 over 10,000. And that is 10 to the power minus 4. Okay. So, Another thing, so you understand that positive exponents, so these are called the exponents. So that's another thing with science is the terminology, right? With chemistry, there's a specific terminology, especially with math and algebra. These are terminology. So when we talk about displacement, we are also looking at the exponents. Exponents and TS. So these guys are exponents, okay? These are negative exponents. Now, positive exponent and negative exponents, there is a difference. So if you know the number line here, number line, let me put this here. So if you recall the number line will show you, let me get this, number line. Okay, now here you see in the number line, okay, so here is 0. All the numbers that are on the right side of the 0 are positive. The numbers that are on the left side of the 0 are negative. Okay, so that's something to remember. So when you move from negative to 0, you're actually increasing. You're going positively, going towards, so this is increase. You will see the increase in the numbers. Or in the numbers getting bigger from a negative to 0 to positive is increasing. But if you go on the other side, let's get this side, going from positive to 0 to negative, in that case, the numbers are going to decrease. The value of the numbers is decreasing. So in other words, just we talked above that 10 to the power 2, 10 to the power 2 versus 10 to the power minus 2. So 10 to the power 2 is bigger. So how do you show bigger sign? Like this. This is bigger than this. So this is another one. So this sign is a bigger sign. So 10 is big. 10 to the power 2 is bigger, and the other guy is smaller. Okay. So another thing. So all this, bigger sign is this, and this side is a smaller number. So all the negative exponents, or the way I put it, I should have, hold on. Let me do it the other way around. Okay, so 10 to the power 2 versus 10 to the power minus 2. So minus 2 is smaller, 10 to the power is bigger. So this is a greater number, greater than, smaller than, and this is a smaller number. Okay, on the other hand, if you have 10 to the power minus, let's say 7 versus 10 to the power minus 5. So in that case, since you're moving, from left to right, so this is the left side. Let me put this here, another color. This is the left side, and this is the right side. So when you move from left to right, so 7, 10 to the power 7. So this is 1, 2, 3, 4. Let's say this is 10 to the power minus 4, and this is 10 to the power minus 1, and so forth. So this is, just going to be 1, 2, 3, 4, like that. So here you will see that 10 to the power minus 7 is a smaller number than 10 to the power minus 5. Same is the case if you have a number like 10 to the power 5 versus 10 to the power 7. So in that case, 10 to the power 7 is a bigger number than 10 to the power 5. So, okay, so that thing. All right. So we can also look at this in the terms of whole numbers. Whole numbers, for example, in this case, let's say 25 and 15. So this would be less than. 15 is less than 25, so understanding that. Okay, so now we're going to look at these integers. So integers are the positive numbers and the negative numbers. So in other words, there is a sign in front of a number. For example, positive 3 and negative 3. and so forth. Okay. Now, keep the thing in mind that here we will have some opposites also. Opposite. So understand this as opposite. Opposite is, for example, the opposite of plus and minus are opposites of each other. And addition and subtraction are opposites. Multiplication and division are opposite. So these signs you should know. Then the square root and the under root, those things. So we will discuss that later, but right now just keep this simple. Opposites of these two. And based on that, there are some rules, okay? Rules also to addition, subtraction, multiplication, and division, where these signs are used. So let's look at some of the rules here. Okay, so what are the rules regarding the addition and the subtraction, multiplication, and division using integers, which is the numbers with the positive and negative sign? So multiplication. So when you have a positive number multiplying by a positive number, the answer is going to be positive. Okay, so how do I show this? This, I think I should do multiply. Okay, when you have another thing is, when you have a negative number multiply by a negative number, the answer is positive. Okay, when you have a positive number multiply by another number that is also in a bracket but negative, okay, and this is multiplying, but positive and negative makes negative, so the answer will be negative. And when you have the number which is a positive, a negative number in brackets multiply by a positive number in outside the bracket, doesn't matter. So this sign is also going to be a negative sign. So here you will have a, why do I keep doing this? Okay, so this is positive and the answer will be negative. So these are the basic rules regarding the addition. The same applied to the division also. So let's see. Let me just make this small if I can. Okay, here. Okay, now let's look at the division. So division is when you have a positive number, and here you're going to, in this case, let's show it as a fraction. So if you have a positive number over another positive number, in other words, as a fraction, okay, as a fraction. So in that case, this answer will be positive. When you have a negative number, divide by, fraction means now here you are dividing. Okay, so here a negative number divide by another negative number, the answer is going to be positive. So minus signs cancel out. But if you have a negative number divide by a positive number, the answer is going to be negative. And if you have a positive number divide by a negative number, the answer is going to be negative. So it's just, so just remember that in fractions, you are going to be doing this division. So these are going to be fraction numbers in the fraction form. Okay, so that's one piece. So here, let me just do this, divide for the fractions. These will be numbers in fractions, divide. Okay, now addition. Now addition and subtraction. So if you have two positive numbers and they are being added, and here you will see in that case the answer is going to be positive. So the answer is positive. If you have a negative number and you're trying to add to another negative number, so in that case what happens is that when you add them, minus become plus, but the sign is going to be of a larger number. Okay, so here minus is a positive positive, it will add up, okay? But the sign, negative sign of A, so the sign will be, you will add, so let me write this down. How do you write this? Add. So this is added, but the sign is of larger number. Okay. Next is if you are, let me put the numbers here so it becomes just easy. Hold on. Okay. Sorry about the previous snafu. Here I have better examples. Okay. So here we have the multiplication rules. Positive and positive multiply, positive and negative subtract, negative and negative, you know, the sign becomes a positive and they're multiplying. And then minus sign multiply by a positive sign, the answer will have a negative sign. So this is one rule. Second is about the fractions. Whenever you have the fractions, that means you're going to divide. So positive, two positive numbers divide, the answer is positive. Two negative numbers divide, they cancel out. The negative signs cancel out and you get a positive number, right? Then you have a minus divide by a positive number, the answer will have a negative sign. Similarly, a negative number, when it's divided by the positive number, the answer will be negative. So when we don't write, so positive, you know, when we write positive, so it's okay. Sometimes, you know, we don't put it. So not, you know, not put in front. Sometimes, depends, you know, what we are doing. So sometimes. But that means that this is a positive number. This means it's a positive 6. Okay, positive 6 or any positive number can be written like this. All right, next is divisions. We did that. Now comes the additions and the subtractions. So here, when two positive numbers are added, positive answer. Now, when two negative numbers are added, the answer is positive. You're going to add them. So because minus minus becomes plus, but the sign is going to be of a larger number. So this is the one that I was trying to make, larger number. Next is when a positive and a negative number are being added, you're going to subtract. So minus plus becomes minus. But when you're adding, but the sign is going to be of a bigger number. So here the bigger number is 15. That's why the answer is minus 3. Okay. Next is when minus sign is being added to a positive sign. Again, in this case, the positive one was a bigger number. So in this case, the positive sign, that's why you have positive, but minus plus is minus. So that's why we subtracted. So this is one rule. Next is regarding the subtraction. Same thing, positive and negative. When positive and positive are being subtracted, so remember that when brackets, you know, brackets means multiplying. So when negative and positive, you know, in the brackets are like in brackets, that means when you open the brackets, this is multiplication. So in a way, this is multiplication. You know what? I am a chemistry professor. I'm not a math professor. So obviously, this is the first time I'm actually teaching like just the math. We just look at the applications of this in science and it just works. But I hope I'm making myself, you know, as clear as is possible. But, you know, that's what it is. So anyways, so here we see that negative and negative numbers when they are multiplying. So this would be, this means multiplication. This means multiplication. Okay, where I put the dots. So, so these are multiplications. Okay. All right. So 12 minus positive 5 becomes minus. And the sign is of a big number here, 12. Next is the positive minus a negative number. So minus minus become plus. So you see right here, plus. But the sign is of a big number. Minus and minus multiplying becomes plus. And here then minus and plus minus. So here this is negative, this becomes a positive, and then this becomes a negative. The sign will be of the bigger number. And then here minus, minus and plus minus. So minus minus becomes plus, but the sign is, so this is added, but the sign will be of a bigger number. So just, with practice, these rules come through. But let's look at the next part, which is now using the calculators and, addition and subtraction, rounding up. So let's look at some of the rules regarding the rounding up. 2. So this is part 2. Let me just. Okay, so these are the rules regarding the rounding numbers. So first of all, you have to identify the significant figures. How many numbers you need to keep in a, in a calculations, and then what numbers need to be dropped. So significant figures, these are going to be discussed in chemistry class. So these are the part of the chemistry course. And so you will refer them to the handout. Okay, you can look at the handout for that, or you memorize, that's even better. But based on that, next thing is you only round up and write down the final answer, because this is just cosmetic fixing of the numbers. Okay, the final numbers. So just the answer, nothing else, nothing in between, no steps. So anyways, if the dropped number is more than 5 or equal to 5, then you round up the number that is on the left-hand side. But if the drop number is less than 5, then just keep it as it is in the chemistry. Okay, so like for example, let's look at this number. So we have this number 2.4697. Okay, let's say the significant figure says that, we need the answer up to 1, 2, 3, 4 places. So we need the answer up to 4. So let's say if the answer is saying 4, or if your requirement is to have 4 significant figures, in that case, what you're going to do is you are going to, hold on. So in that case, you're going to keep 2, 4, 6, 9, but you're going to drop 7. Okay, but 7 is more than 5. Okay, so what happens to 9? Then for 9, you're going to add 1. So it becomes 10. So in that case, that 1 gets carried over. So 1 gets carried over. Okay, to the next number on the left. Carried over. So let's see what then this becomes look like. Okay, so here we are going to have 2.4. Okay, 7 got dropped. 9 gets this 0, but the 10 gets carried over to, that 1 gets carried over to 6, to 6. So then 6 becomes 7. Okay, so like that. So this is one piece, right? And second thing is, let's look at it another number. If you have 2.46972, and here let's say you need to keep 1, 2, 3, 4 places after the decimal. Okay, sorry, and 5 places. So we need to have 5 significant figures. 1, 2, 3, 4 places after the decimal, but 5 significant figures needed. If it's needed, okay, we need to have this number. Then what do? You are going to take, in that case, drop 2. But 2 is less than 5. Therefore, 7 remains as is. Okay, like that. So that's the way. So now our new number becomes 2.469 and that's going to be your answer, the final answer. Okay, so this is only done, rounding is only done in the final answers. Okay, now we are going to look at the use of calculators and then addition and subtraction. So first part was rounding, and then the second part is addition using the calculators and subtraction. So addition Now, very simple addition and subtraction. In the calculator. And these are the whole numbers. So we are going to first look at the whole numbers. Okay, here in the calculators. How to use them. All right, so here is a calculator. All right. Oh, okay. Okay, so as you can see, we are just going to use the basic one here. So this is the addition sign. So 3 plus 2 equals 5. Okay. 6 plus 9 equals, wait a minute, I think 5, clear. Okay, clear. 6 plus 3 equals 9, right now. Okay, so this is all clear. AC stands for all clear. Let's say you have to subtract. So 6 minus 2 equals 4. Okay, and then clear. Then let's say 10 minus 6 equals 4. Okay, so this way. So this is a very simple basic function of calculators. Next is for the addition and subtraction. So same story, addition, the multiplication and division, the same story. Okay, so just remember that the calculators, we will for now, same thing. Let's look at the simple division. 6 divide by 2 equals 3. So here I'm using 6 and then the division sign by 2 equals 3. For example, 3 divide by 3 equals 1. Okay, clear. Got it? So 5 divide by 2 equals 2.5. Clear. Let's do 782 divide by 24 equals 35.583333. Now, based on the rules regarding the significant figures, which we will do in the class, and also how many you need to keep after the decimal. So that's all going to be determined. But for now, this is the number that you're going to just take out, few places after the decimal. If no rules regarding the significant figures are, being applied, so we only use significant figures in the case of measurements. But if no rules regarding the significant figures are applied, in that case, you only use 2 places after the decimal. Okay. All right. So let me put this here. Okay, so I wrote this here. So that when the significant figures are not used, not all the questions you will be using, some of them where the measurements are, being applied using the apparatuses, there we use them very specifically. So in those type of calculations, we use significant figures. Otherwise, it's okay to just have 2 places after the decimal and they are good enough. Okay. Now, the next thing we are going to look at is the solving equations. Okay, so hold on. Okay, so here we are going to look at very simple equations. So here in an equation, so equations are coming from something, an expression that is equality, that involves equality, equal. So one side is a variable, the other side is a numerical value. Both of them are equal. The only difference is we do not know what is the value of n, but we know that with that unknown value of n, that unknown that is expressed as n, you can also put it as x, y, a, b, c, m, n, whatever. Doesn't matter, but it is unknown. But when that unknown value is added to 4, then it becomes 9. How do you find the value of unknown? So just always keep this in mind about the opposites. That positive and negative are opposite of each other, and negative and division and multiplications are opposite. So let's solve this. So n plus 4 is equal to 9. So one of the rules is that you always try to bring the whole steps is to bring all the like terms on one side and keep the unlike terms, separate them from the like and the unlike. So n is the unlike, n like 9 and 4 are the like terms. So what are we doing here? We are going to cancel the 4 from one side. So how do we do that? So n plus 4, remember, and this is minus. Positive and negative cancel out. And here is the 9, but minus 4. So you need to bring minus 4 on both the sides so that minus 4 cancels out from one side. So it just leaves one unknown or the unlike term on one side, and 9 minus 4, solve it, it becomes 5. You can check your answer also. You can check. So when you check, nothing else, but it's just going to be 5 plus 4 is equal to 9. So this is a very simple expressions, of solving the simple equation. Let's look at another equation which involves multiplication and division. Let me get some example here. Okay, so here we have another expression, 3n is equal to 15. So find the value of n. Okay, so what is n? So here we will see that this means 3 is multiplying by n. So the sign is a multiplication sign, and this is equal to 15. So having decoded that, now we know that bringing the like on one side and the unlike, keeping the unlike on the other, or the unknown on the other. So what do? If 3 is to cancel 3 from, or to relieve 3 or to release 3 from this n, what do? Divide. So opposite, remember. So times n, and then division is this. This is division. Okay, and then equal to 15 divide by 3. Okay, so this is divide by 3 on both sides. So this is something sometimes students don't know how to do it. So now what's happening here? So we see that 3 and 3 cancel out, okay, from one side. And now we are just left with n. And you have 15 divided by 3. So punch this number on the calculator. Let's do this here. So all clear? 15 divide by 3 and you get 5. Okay, so this is equal to 5. And so n is equal to 5. That's the value of the unknown. Okay, so this is one thing, solving the equations. And let's see what else is left. Solving equations, these. Now comes the order of operations. Okay, this is the third. So you will have to do practice, that's it. So fourth, order of operations. Now, everyone heard of the PEMDAS, okay? So order of operations. Now, if you have addition, subtraction, multiplication, division in an expression, how do you find the answer? So here you have the rule. Please excuse my dear Aunt Sally. So PEMDAS, PEMDAS. So P stands for parenthesis. E are the exponents, like for example, x raised to the power some number, some exponents. M is multiplication. This is division. This stands for addition. And this stands for subtraction. Now, the only thing is that the multiplication and division go side by side, and then it go together, and then the addition and the subtraction go together. Now, multiplication and division in one, but left to right, whichever comes first, you will solve it that way. So left to right, whichever one comes first, whichever comes first. Means if multiplication comes first, then you multiply. But if division comes first, you divide. Same is the case with addition and subtraction. If addition comes first, you add, but it's not necessary. If subtraction is coming first from left to right, you subtract. So, okay. Now, let's look at one example. Okay. Okay, so this is our example. And here we see that 18 divided by, in the parenthesis, is 6 plus 3. Now this sign means, the dot sign means multiply. This means a multiplication sign. Okay, and then 4 squared, this is the exponent. So we are going to use the PEMDAS rule. So first brackets, okay? So 18 divided by 6 plus 3 is 9. Okay, so let's put this in 9 only. So we solve this. Multiply by 9 minus 4 square. Okay, so next is the exponent. So 18 divided by, so leave it like that. So otherwise that 9 confuses. 9 minus 4 square means, this 4 square means 4 times 4. So this is another thing we're going to cover. 4 times 4, okay, is equal to 4 square. All right, so this becomes 4 square, and that is 4 times 4, 16. So this is minus 16. Okay, next. Now, we have a scenario where you have division and multiplication in one set. So we are going to, because division, so remember, PEMDAS, multiplication and division. Multiplication from this is coming, but from left to right, division is coming first. From left to right, division coming first. So we are going to solve that first. Division coming first. And so here we have 18 divided by, so this means 18 divided by 9 will be done first. And that gives you 2, right? So then it becomes 2 times 9 minus 16. Okay, now you're going to do this part first. Okay, so then this becomes 2 times 9 is 18 minus 16. And that gives you the answer 2. And that's the answer. Right answer. Okay, so use this method. Let's do another one. So if we have an expression like, for example, let's do this one. Now, because it's an algebra, so A has some value, B has some value, square plus 3C. Okay, so A is equal to 6, B is equal to 4, and C is equal to 1. Okay, so first thing to solve these type of problems, now you're going to plug in the numbers. So A stands for 6 minus B stands for 4, brackets, square, plus 3C means 3 times 1. This is what it means, 3C, okay? So 6 minus 4 is 2. So 2, solve that first, exponent plus 3 times 1 is 1. Next is 2 square means 2 times 2 is equal to 4, okay? And then 4 plus 3 is equal to 7. And that's the answer, okay? So that's how, you bring in the variables. So if the variables have some numerical value, and then you plug that in, and then this is how you will be solving. So this completes this part, solving equations, order of equations. Now we're going to look at a little bit into fractions. Hold on. Okay, so now we're looking at the fractions. Okay, so here the fractions are basically like the whole and then the small part of the big whole, okay? There are 2 parts of the fraction. The number that's written on the top is called a numerator. The number that's written at the bottom is the denominator. So small part of a big whole. For example, this part, the colored part right here, this part. So this part is equal to x is equal to half. One part, of that, like that one part of the whole thing is divided into 2 parts, and we are looking at the one part of the big whole, the big thing. Next is 1/3. The third third part, okay? 1/4, the fourth part of the big whole, okay? So that's the one part, one thing. Okay, so maybe I wasn't saying it correctly or confused, but here, okay, so this is what exactly it means is if two parts, and out of those two parts, there's one part that is a half, the one that is shaded. Similarly, there are three parts. Out of the three parts, the one part out of the three, that is a fraction. That is, the part, the x that's shaded. And similarly, if there are four parts, out of those parts, the one part is that x 1/4, okay, and so forth. So this is how, you will write. Then there are simple fractions and there are improper fractions. So simple, and there are improper fractions. So right now, the one that I have written, these are all simple fractions. Improper fractions are, you have to simplify them. So for example, simple fractions are like, for example, 5 divided by 7. So they cannot further be subdivided, cannot be simplified. Like 3 divided by 4, like 6 divided by 6 divided by, let's say if it's 6 divided by 9, then you have to simplify it. Okay, so you have to look for a common multiple. So which is the common multiple here? Common multiple is 3. So in other words, this becomes 3 times 2, and 3 3s are 9. So this is the simplified version of that. So simple fractions become like that. But improper fractions are, for example, 4 5/6. Okay, so what does this mean? This means 4 times 5/6. And how do you solve this? You solve it as, so go like this, like that. Okay, so what is this? So 4 times 6, whatever the answer comes, and then you add 5 to it. Okay, and then that gets divided by 6. So then divide by 6, or over 6, then divide by the 6. Okay, so in other words, I don't want to confuse. Let me see if I can write it correctly. So, yeah, so this is the way, over 6, like that. So this becomes 24 plus 5 over 6. And then 24 plus 5 is 29 over 6. So this still is an improper fraction, but like it's an improper fraction, but mixed fraction, what is it called? Mixed, yeah, this is a mixed fraction. So using the mixed fraction and convert them to an improper fraction. So improper fractions will have a larger numerator. Okay, so this is the reason why you make them into these mixed fractions to begin with. But that's about the fractions, understanding the fractions. Let's look at some of the other calculations. Okay, now we're looking at the multiplication of the fractions. So if you are given these numbers 3/8 and there's a dot means multiplication sign. This means multiplying sign. Okay, so how are you going to do this one? So this is going to be 3 multiplied by 4 divide by 8 multiplied by 9. So 3 4s are 12 and 8 9s are 72. And then you further simplify. So just don't leave it like that. Further simplify. And so here, what do you get? Okay, so see, sometimes, you need the tables. You need to know the tables, but sometimes you forget or you don't know it. So how do you do this one? So 8 multiplied by 9 equals 72. Okay, so now here we have, that's how, in case you don't know, 72, that's how I got. Okay, next, we need to simplify. Don't leave it like that. Simplify means that because, remember those numbers, the even and the odd numbers, that also you need to know. So this is an even number, and this is also an even number. So if there are two even numbers, that's the thing. If there are two even numbers, these are all odd numbers. These are odd. Sorry. Here. This is an odd number, odds, two odd numbers, but these are there. We look for a common multiple, although 9 is an odd number, but 6 is an even number. But still, we look for a common multiple in C. And then we finally got like this type where they're not the same. So same thing, even and even, we need to look for further simplification of that. So we have here all clear. So 12 divide by 72 and you get 0.16666. So just write the answer here, 0. So this the answer is 0.166, and you can leave it, or you can 0.17. So that's cosmetically. So all this, all these numbers, you can do this way. So this is one set. Let's look at it another example. Okay, so here we have these numbers. These are in brackets. So even though there is a minus sign, it doesn't mean that they are being subtracted. And even though there's nothing written here, nothing is here, nothing here, this means that this is going to be a multiplication. So this implies multiplying, this implies multiplying. Okay, so in other words, this whole thing is multiplication. So now remember the rules. So minus multiply by minus multiply by minus. This is what's going on. So minus sign multiply by minus sign. So this is one way you can do minus. So minus plus, but then there's another. So even if you do this, minus multiply by minus becomes a positive sign, but then it's multiplying by a negative sign, right? So this becomes a positive sign multiplying by a negative sign. So then what's the answer? The answer is going to be the negative sign. The answer will be a negative number. Okay. Now, so what do we do here now? We have, look at this, how will we solve it? So as I said, minus 3.8 multiply by minus 2.5. So this becomes plus. So let's put this here, minus, and this is minus. In other words, they cancel out. So it becomes positive. All right. Next is multiply by negative 10/21. Okay. So we know the answer is going to be a negative number, but now let's look at the calculations. So here, 3 times 2 times minus 10, divide that whole thing by 8 times 5 times 21. Okay. So one way is you can put all these numbers in the calculator. 3 times 2 times minus 10. So 3 2s are 6. So this becomes minus 60. Divide that by 8 times 5 times 21. So let's look at this one. 8 times 5 times 21. 8 times 5 times 21. And you get 840. So write that down, 840. Okay. And then you can do this minus, and then this will give you a decimal. Okay. Another way would be that you can look for, the simplest. Simplify this. So simplify this. 60 divided by 60 and 840. So 60 and 840. 14. Sorry. 60. Wait a minute. Hold on. Okay. Another way is you can do, so here you have 60 and 840. So cancel out the zeros and you have 6 divided by 84. And then, this is in the 14th table. So this is 1/14. This is one way you could do. Another way you could simplify it and simplify it in the other way, which is 3. So another, alternatively, ALTERNADIVELY. So this piece we did by the calculator. Okay. You can use the calculator to do all these calculations. Or alternatively, look at this: 3 times 2 times minus 10. Divide that by 8 times 5 times 21. So if you look at it, 3 ones are 3, 3 sevens are 21. Okay. 5 ones are 5, 5 twos are 10. So this gives us 2 times 2. And then here you have 8 times 7. 7 eights are 56. And then 2 times 4. So this is going to 1, 14. 14 4s are 656. So that's another way you could do it. Okay, so that's all, simple calculate. I would say if you could do the calculator, you might make less mistakes. Okay, so that was about the fractions. Let's look at what's next. Okay, fractions, solving equations with fractions. Now that's where, you are going to be needing the little. Okay, now let's look at solving equations where fractions are there and solving for the unknown. Okay, so here's a simple example. X over 5 is equal to 2. So X and 5 are dividing. And like we said, all the like terms on one side, unlike on the other side. The rule, opposites of addition, subtraction, multiplication, and division remain the same. So as I said, addition and addition and subtraction go together, opposites, and multiplication and division, opposite. Okay. So here we want to bring the like terms on one side. So how are we going to do this? So we are going to keep X on one side, and we need to get rid of 5. So X and 5, division is involved. So in order to get rid of 5, we will have to multiply by 5. So here, multiply by 5 is equal to 2 multiply by 5. So multiply by 5 on both the sides. So this cancels out the 5 from one side, and you are left with X is equal to 10. Okay. Next is this one, 3/4 A is equal to 12. So we need to get rid of 3/4 from one side, bring it on the other side. And in order to do that, we have 3 over 4 A. So if you multiply this by the reciprocal, 4 over 3, okay? So that will allow you to cancel out 4 diagonally and 3 and 3 diagonally. And so you are going to now multiply by 4 over 3. So keep this in mind that 4 and 4 can cancel out. 3 and 3 cancel out. So when they cancel out, it just becomes 1. So it leaves A. So it's just 1A. And now you have A is equal to 12 times 4. Now here to solve it, 12 times 4, 12 times 4 divide by 3. Now you can just do it. You can do it simple way also, but let's just do it using the calculator. Okay. 12 times 4 divide by 3. And what do you get? 16. So that's the answer. 16. Okay. Now we have another one, minus 3C over 5 is equal to 6. So in that case, same thing. The only problem here is this guy. Because unknown number, we cannot be a negative. So what do? We will have to bring in like the positive. So we have to make it positive. So in that case, minus 6. So here, the minus sign will have to be brought on the other side. So just give me 1 second. Yeah. So here we have, sorry. Okay, so here we have, so this means, sorry, oh, Okay, so minus 3 over 5. And the opposite of that is, this is times C, okay? The opposite, so multiply this. The opposite of that reciprocal is minus 5 over 3. 6 multiply by minus 5 over 3. So minus 5 over 3, we need to get rid of the minus sign also. So this way, you see minus and minus becomes minus multiplied by minus is a positive sign. So that cancels out. 5 and 5 cancel out. 3 and 3 cancel out. And you're just left with C. C cannot be like a negative sign. So that's why we needed to do this. So in this case, you will have C is equal to now minus 6 times 5 divided by 3. 6 times 5 is 30 minus divide by 3. So the answer is minus 10. So C is equal to minus 10. Okay, this is the way to do it. Next is if you have something like this. Now here you are given the y. So we need to get rid of, keep the y on one side. So here you're going to be subtracting. So positive 2 over 3 minus 3 over 2 is equal to 3 over 4 minus, what was that? I think I got distracted. Oh, wait, 1 second. Sorry. Hold on. Okay, so here it was a positive 2 over 3 minus 2 over 3 is equal to 3 over 4 minus 2 over 3. So you see here the 2 over 3 minus 2 over 3 minus 2 over 3 on both the sides. So that's how this piece gets cancelled out. This one minus the positive and negative. So this thing cancels, this whole thing cancels out. And you are left with that. Now, how do you solve this? Fraction solving. So 4 and 3, there is the common multiple is 12. 4 times 3 is 12 and 3 times 4 is 12. So 4 times 3 plus 3 is equal to 4 3s are 12, 12, 13, 14, 15. And 3 times 4 is 12 plus 2. Sorry, plus 2, not multiply. So plus 2 is equal to 12, 14. Okay, so here 15 minus 14, and you get 1 over 12. So the value of y is equal to 1 over 12. Okay, so that's one way you could, solving these problems. Next is 3 over 8y, and this is here 3 over 8 multiply by y. This is what it means, is equal to minus 1 over 4. Okay, now the only thing is 3 over 8 multiply by y multiply by 8 over 3 is equal to minus 1 over 4 multiply by 8 over 3. So remember that reciprocal. So here 8 and 8 cancel out. Sorry. Ooh. 8 and 8 cancel out. 8 and 8 cancel out. 3 and 3 cancel out. And that's this way. So reciprocals. Okay. So minus 4. So you can also simplify this. 4 2s are 8. And so this is minus 2 over 3. Without using the calculators and all you can use. So know your tables, okay? So if you know your tables, so it can go faster. All right, so this finishes this part, number 7. And this was a huge. Number 7 was solving equations with fractions, okay? Next is the radical expressions. Here, let's look at the perfect squares. Okay, so here, for example, 1 times 1 can be written as 1 square, okay? 2 times 2, so that's the number that multiplies to itself, is 2 square. And the value of this is 4. 3 times 3 is equal to 3 square, and that the value is 3 times 3 is 9, right? 4 times 4 is equal to 4 square, right? And the value is 4 times 4, 4 fours are 16. 5 times 5 is equal to 5 square, and the value is 5 fives are 25. Okay, similarly 6 times 6 is equal to 6 square, and the value is 36. 7 times 7 is equal to 7 square, and the value is 49. 8 times 8 is equal to 8 square, 64. Okay, 9 times 9 is equal to 9 square, and this is 9 nines are 81. And then 10 times 10 is equal to 10 square, and the answer is 100. Okay, so this is the very general smaller terms, but you can, a number when multiplies to itself, will give that. So that number is a perfect square. Opposite of the square is square root. Okay, so the opposite, these guys also. So the opposite, let me write down here, opposite of a square, is equal to the square root. Square root. And square root we show like this. Okay, so let's look at it here. For example, if you are given one example here, 25. Okay, so this 25, the square root of 25 is equal to 5. Okay, and this can also, so basically, yeah, so in other words, we can also write something like this, like 3 square, 3 threes are 9, and this can also be written as under root 9. Okay, so that's so they are opposite of each other. Okay, to solve this is how you will do, and you're going to need this, when you do the rates of expressions and those the equilibrium constant, all those things. Okay, now if you have the signs, let's look at this one now here. See, now let us say you have a sign here, negative 49. Okay, now this negative 49, what does that mean? Negative 49, that means it is talking about 7, but it's negative 7. So the sign, remains the same. On the other hand, if you have to add or, those things, so if you have to add, you do it. But if you have a numbers like this, let's say simplifying D, you have a number like simplify under root 1/9. Okay, so in this case, what do you do? So we know that 9 is the perfect square of 3. So this becomes yeah, so this can also be written as 1 over under root 9, and that is equal to 1/3. Okay, so this can be written as this, but this 3 is basically, it's going to be squared. So basically this whole thing can also be, so this is a square. Okay, because the 9 squared, so this under root and 1/3 squared can be written the same expression. Okay, so you will need this. Let's say you have another one. Let's do another one. DE. You have under root 4/25. Okay, so here you are going to see 4. 2 times 2 is 4, and 5 times 5 is 25. So this and this go like this. This can be expressed as this. So the under root of 4 so basically this whole thing is means the same, but when you simplify it, so this final answer is 2/5. The square root of 4 over 25 is 2 over 5, because these two are the same, right? And same is the case for the other one, which I did. I have made a little mistake. Yeah, so this thing, the answer is 1 over 3. That is for this guy, 1 over 9. Similarly, this is the answer for 4 over 25. Okay. So this is one piece regarding the, using the square roots. Now, if you have numbers like 3 times square root 5, so how do you solve this? So basically, this means 3 multiply by, you're going to put on the calculator, 3 multiply by 5, and then, click on, so let's click the 3 times 5, and then the calculator, this sign, and then the equal to sign. So, or you can also do 3 under root, and then 5, and then hit the equal to sign or enter. Okay, so this is the way you are going to punch the numbers on the do this on the calculator this way. Because the problem is my calculator on the iPad is not showing the sign, so that's why. So here, if you see, so 3, so under root for the 5 is 5 under root comes out to be 6.7. No, sorry, this comes out to be, I don't know, it's 3 times. Yeah, so 3 times under root 5 is 6.70. Okay, so that's the answer. So this is the way, you will use the calculator. So this says also from the calculator as this function. Okay, all right, let's look at it another example. Okay, so next we're going to look at the 2 other types of rules of multiplication and division where there are monomials. For example, if you have something like x raised to the power of m, and it is multiplying with x raised to the power of n, so the powers are different. So in that case, you multiply x and x the way you do, but the power m and n are going to be added. Okay. On the other hand, if you have an expression like this, x raised to the power m, m stands for some number, and n is outside the bracket, in that case, multiplied. Okay, so we're going to do some problems here solving these. Divisions. In the divisions, if you have 2 numbers, same numbers, with the, the numbers are different, but it's the same, like the same numbers, but the powers are different. So in that case, if they are dividing or in a factor present, then minus, subtract. But x raised to the power minus, whatever number is, then that means 1 over, so it's a reciprocal. Okay, so these two are there's a very important opposites. So let's do some problems here. The first one where we are going to see, the first one is multiplication. Okay. Multiplication where the monomials, and you will get these, for example, you have a problem like, let's say do this one, minus 6 C5, okay, brackets, multiply by 7 C8. Okay, so here, how would you do this one? So in that case, you are going to see that minus 6 and 7, positive 7, will multiply together. What do we do with the C? The C is, on the other hand, the C will multiply the way it is, the C, but the 5 and 8 are going to be added, just like here. So 5 and 8 will be added. So then this gives you the answer. 6 sevens are 42, but sign is going to be of the negative number. And C, and 5 plus 8 is 13. That's the answer. Okay, so this is how you will solve. Next is, for example, you have some number which is, let us say, 1 second, maybe I left something. Hold on. Okay, so there's one more rule which I forgot. So if you have a number that is raised to the power some number and different number raised to the power, right? So in that case, what do? You keep them separate, these two numbers, but these powers, they multiply. Okay, so now let's look at this one problem here. One problem. So let's say we are trying to simplify 5x raised to the power 2, 5x raised to the power 2 multiply by, raised to the power 3. So in that case, what happens? This 3 applies to x, the 5, and this 3 applies to x also. So what do we do here? So 5 raised to the power 3 times x. Now what happens to 2 and 3? 2 and 3 are going to multiply. So 2 times 3. So here you will see this becomes 5 times 5, 5 times 5 times 5. Okay, and then times x, and 2 3s are 6. So this answer becomes 125, 125 x raised to the power 6. So this, these type of problems may arise. See, and then let's see another example here, which is, let's say, minus 2, okay, minus 2 p raised to the power 3 or raised to the power 4. Okay, so here what you will get, so this is, that means minus 2 raised to the power 4, right? Multiply by p 3 times 4, multiply by r to 4. And so here you will get minus 2 times minus 2 times minus 2 times minus 2, like that, times p, 3 4s are 12, times r raised to the power 4. So 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. But it's all going to become the cancel out. So this becomes 16 p 12 r 4. Okay, so that's like, some problems you might get, but not necessarily, okay, you would get, so, when we do the last problems in the end, then you might see these. All right, let's look at what else. Okay, so we need to do some division problems also. So let's say you have 1a raised to the power minus 8. So this thing can also be written as a raised to the power 8. Okay, this can be written like this also. Next is EF. Next is, let's say you are given 3 raised to the power minus 4. So this can also be written as 1 over 3 raised to the power 4. 1 over 3 raised to the power 4. And this is equal to 1 over 3 times 3 times 3 times 3. So that is equal to 1 over 3 3s are 9, 9 3s are 27, 27 3s are 81. Okay, so that way. Okay, F, G, let's look at it. Another problem for the division is b raised to the power 2 over b raised to the power 9. So here you will do b, you will see these, as you go. So 2 minus 9, okay? And this gives you b raised to the power minus 7. And that can also be written as 1 over b 7, okay? So either way, so these type of problems you will see. Okay, so the next is the graphing, which you will see, in the chapter on gas laws, and some of it we are going to do in the lab as well. So here there are two, coordinates, and x and y, right? And here you will see the y, x is the independent variable, y is the dependent variable, okay? Some numbers you place here when you gather the data, there's some range of numbers. So you place them here. And for example, this is the temperature, the degree Kelvin. Okay, since you're taking the data, we can just put it here as Celsius, degree Celsius. Okay, and here is the volume in milliliters. Okay, so the units are important. Otherwise, these numbers don't make any sense. So here you have the degree Celsius. You're gathering the data. And now you gather some data points. You see, as you increase the volume, as you increase the temperature, the volume keeps increasing. Okay. If you gather a few data points, but it's very important that, dot these lines into a straight line. Okay. So this is a line graph. So you should be able to find the unknown. All of these dots should match. So this number and this should match. This and this should match with your, whatever experimental values you have. But you can find the unknown using, the limit, the set of data. So if you want to find the unknown, that at a very specific temperature, right, what is the volume? So you can, get it like that. So on the test, you should show this, how you're getting that dot and how it, it matches with the numbers on the x and the y axis. Okay, so that is the unknown. You can find the value of the unknown, the volume of the unknown at a specific temperature, or what is the volume, when the temperature is something that that you can just get from the graph. Okay, now graph the slope. So the equation is y is equal to mx plus b. That's for the linear. But then also there is a term called slope, rise over run. So, in the lab, you will be given the graphing paper, and then you can determine the slope from there as well. Okay. So that's like understanding the graph. And so it's very important that you draw, a straight line or the line that is of best fit line that best fits the line. So it could be, let's say you're not getting it exactly straight, but try to plot the near the dots. Okay, the last is, so this was a simple, graphing intro. So we are going to do more in detail when we go in the labs, but for now, this should, at least you should have some basic understanding. Next comes the conversions, then percentage and statistics. Okay, now we are almost to the end. Conversions. Okay, now we will do these more conversions, but just so you know that the units can be converted. Okay, so conversions using the dimensional analysis. So one method is using dimensional analysis. Okay, and the second one is using algebraic conversions. So both. Okay, so dimensional analysis is a different method, and then this is different. So we are going to cover more in depth the dimensional analysis, but let's say, for example, let's get some simple examples here. Okay, let's look at the conversions using the dimensional analysis. So here you're going to be given some, equalities where the units are being equalized. So like, for example, a situation where these are given, these are known or given, and the given in the tables or in the questions, and you need to set up the problem. Okay, so here you are given, this is known. So in other words, these are known equalities where 1 gallon is equal to 4 quarts and 1 quart is equal to 946 milliliters. Let us say the question is saying convert or find how many, like 2.5 gallons is going to be how many milliliters. Okay, so how do you set this up? So this is the way we do 1 gallon over 4 quarts. These are the conversion factors, or 4 quarts over 1 gallon. Okay, next is 1 quart over 946 milliliters and 946 milliliters over 1 quart. So what is the meaning of that? This means that these conversion factors we are going to use because there's no direct conversion. We don't see in this relationship, we do not see a direct conversion. So we see indirect conversions. Okay, we will have to go through 2 steps. So not 1 step. So we will create these conversion factors, and the ones that are opposite will cancel out. So you're also always going to start with what is given. So you are given 2.5 gallons. So write down 2.5 gallons. Okay, we need to cancel the gallons. And what do we need to find? We need to find how many milliliters is that. So the unit for milliliters is going to be on the top. Now you're going to multiply by that conversion factor that cancels out the gallon. So this is how you will set up the equation or this problem. Okay, so here is your milliliters. And so first the gallons will cancel out. And so if you look at it, and then we don't need the quarts, we need to cancel out the quarts as well. So quarts are going to be here. So now you look at the relationship between the gallons and quarts. Quarts come here, so that the quarts and quarts cancel out, gallons and gallons cancel out. And milliliters, 946 milliliters is here, because that's milliliters is what we want. So when you set up the problem like this, you can clearly see even before setting up, gallons and gallons cancel out, quarts and quarts cancel out. So, they have to cancel out this way. Now you can punch in the number. So 1 gallon is 4 quarts and 1 quart is 946 milliliters. Now here you are going to multiply 2.5 times 4 times 946 milliliter over 1 times 1. And that gives you 2.5 times 4 times 946. So this will be, you will have to put this in the calculator. So 2 times 5, let's do this, clear. 946 times 2.5, sorry, that's the thing with this. Okay, go ahead. 946, 2.5, and 4. 946 times 2.5 times 4. What am I doing here? Sorry. 946 times, what's happening here? Sorry. 946 times 2.5 times 4 equals 9460. Okay. So here you have 9460 milliliters over 1. So, but the answer is, that is going to be the answer. So we are going to do, in further chapters, some dimensional analysis. So you get an idea, because this dimensional analysis will be used in stoichiometry. So just so you know. Next is the algebraic conversion. Now let's look at that also, where you're given a formula and you will be using that formula to, find the unknown. So give me a minute. Okay, so our next is using the formula to find, so you are to convert. In other words, this is a conversion of a problem. You have degree Fahrenheit, you need to find, right? And you are given, so converting the degree Celsius 2 degree Fahrenheit. So this is the formula. So in science, in chemistry, you always have to write the formula. Okay, so here, plug in the numbers, write the formula, and then plug in the numbers. TF is what we are finding. 1.8 multiply by 25, okay, plus 32. So here, 1.8 times 25. You're going to do that. PEMDAS, clear. 1.8 times 25, and that is 45. So this is equal to 45 plus 32. So here, 5, 6, 7, and 4 plus 3, 7 degree Fahrenheit. That is the answer, TF. So this is, when you convert the Celsius and Fahrenheit. So these type of formulas, okay? Okay, so the next thing we have is the percentage. So percentage is also like a parts to whole, okay? So here we have, for example, the question is that what percentage are the boxes blue? So what percent are blue boxes or blue colored? So here we see, if you count the total, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the total boxes is 20. Okay, total boxes 20. Okay, and 5 boxes are blue. So what do you get here? 5 boxes are blue. So in that case, 5 blue boxes is a small part of the big total. So total 20 boxes times 100%. So what do you get here? How do you solve it? You will solve like 5 times 100 divided by 20. So this becomes 50 divided by 20, right? Or 5, sorry, 500 divided by 20. So 500 divided by 20. Yeah. So cancel these out. So 225. So this becomes 25% boxes, not at 25 boxes, but 25% are blue boxes. Okay. So this is, I'm just understanding the basics of percentages. Let's see if I can get another problem here. Okay, so this is another problem. What is 25% of 800? So here you will see 25% of 800 means what is. So what is can be X. X is can be equal to. So that's what, it translates as 25% of means multiply 800. So this is how you translate this language. The rest is just math. 25% means 25 divided by 100 into 800 is equal to the X. So here you will get 25 times 800 divided by 100. So the answer is, so let's get this just for your sake. So clear, 25 times 800 divided by 100. And the answer is 200. Okay. So that is, X is 200. So 200 is 25% of 800. And you can check it also. This also is 200 divided by 800 times 100. So that will give you 25. Okay. So this is the very basic thing about the percentage. And the last is the little bit of the statistics, but the other pieces we are going to do in the class, right? There's a lot. I mean, this is just so basic things, very basic. Other stuff we will do as we go. I cannot do all of the what we're going to apply in chemistry here, but statistics. So you should know statistics. It's easy stuff. You should know what is the meaning of average. Average. Okay, average and mean. Commonly, we use this. Okay, and then there's a thing called range. Range is, a set of data, set of like some numbers from, 1 to it. So average and mean is equal to, if you are given like, you add all the numbers, add the numbers, and you divide them by the total numbers. Total, like the exact numbers. Okay, so for example, you are given like find the average of, let's say you have like 2 plus 2 plus 3 plus 5 plus 6, like that, some numbers. You add them. How many numbers are there? 1, 2, 3, 4, 5. Divide by 5. So in that case, you will have 2 plus 2 plus 3. So 5 and 5, 10, 16, 17, 18. That's what I have, right? 7, no, sorry. 2 plus 3 is 5, 5 and 5, 10, 16, 17, 18. Yeah, divide by 5. And then you solve it. Okay, so that would be this thing. So I'm going to just stop here now, okay, because, I mean, there is a lot we covered today, and the rest of it is, I highly recommend that, after this, you are going to, maybe take more practice if you need to. But other than, pretty much if you got this, then you kind of a little bit have a review on your, so stop, I'm tired. All right. All right. Thank you so much for watching, and take care. Bye-bye.